So students, welcome back to our channel, and this is where we try to make mathematics seem a bit more fun. Uh, Today, no, we are not going to be continuing our ITF series. Today we are going to talk about something else, and that is going to be about calculus. I believe my pen has it. Continuity and differentiability. Okay, so let's get into this. I would assume that you have learned what is limit, what are functions, what is left hand limiting value, what is right hand limiting value, and where does at which point does limit actually exist and which does not. I would expect it from you, but I would expect that you know it because you probably already have been taught about this in 11th standard. But anyway, I'm gonna get into this lightly. Okay, what is a function again? Of course, function is a very basic concept. So function is a you can think of it as a machine which takes an input. That's a function f of x, which takes an input f of x and turns it into something else. Let's say it changes into x cube plus 2x. Okay, it changes into this. This is what functions do. They take an input value and do something with it and then give us an output value. Just think of it machines. This is the machine, this is the raw material, and this is the output. This is basically the product that we manufacture using this function, using this machine. Okay. Now, what are limits? Again, limit is basically a concept that where we want to approach a particular value, but the problem is that if we go to that exact values, there is a possibility that something could go wrong, like the function might become, undefined or something like that. Uh, in order to avoid this, we use something called limits. Basically, what does this do is, uh, in limits, we approach very close values to a particular point. Uh, let's say we have this function x square plus 2x. Now, limit is written this way: limit of x tends to 0 of this function x square plus 2x. Now, what does this indicate? This basically represents what this expression basically means is that we are going to write this value in such way, like where value of x is very close to 0, but it's not exactly 0. But since it is very close to 0, we can basically write it right. Basically, replace x with 0. This is definitely a 0, but the thing is that it is still well defined. For this function, if we just take x equals 0, then still this would make sense. This will become 0 plus 0 equals 0. But for there are a few functions. Let's say you have 5 over x. Now, if x becomes 0, then this would be undefined. X can be 0 because x is undefined. But what we can do here is, because if x becomes 0, then this would be undefined. 5 over 0 is infinity, that is undefined. What we can do here is, uh, this function f of 5 over x, 5 over x at x equals 0 is undefined. But as limit of x approaches 0 of 5 over x, now this is not undefined because this is we are approaching a value very close to 0 but not exactly 0. So you can write it like 5 over 0 but the output value would not be undefined. Okay, now let's talk about right hand limits and left hand limits. uh, Basically what this means is that we are approaching the right hand limit means we are approaching a limiting value from the right side of the number line. This is the number line 0 1 2 3 dot dot dot. On this side -1 -2 -3 dot 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 dot. Let's say we've been asked to approach this value 0, this point 0. So we can do it. There are two ways to do it. First of all, you can do it from the left side. Left side of the number line where you can get to very close negative values to 0, and another way will be to get a value that is positive and is very close to 0. There will be two ways to do it. The negative, if we approach this value from the negative side, this will be called left hand limit. Left hand limit LHL, and this we're doing it this way would be called right hand limit or RHL. Okay, we can do it with any other number as well. Like we've been asked to find limit at this point. Approaching it from the left number line will be called left hand limit. What it basically means is that we are approaching this value 2, but from the left side of the number line, which means basically a value that is very close to 0 but is slightly lower than it. When we approach it from the right side, we will be approaching a value that is very close to 2 but slightly greater than it, slightly bigger than it. Okay, this is what left hand limits and right hand limits mean. Now if a function has very well defined right hand limit and left hand limits, then that function does have a limiting value. Let's say we have a function f of x which is x square plus 1 when x is bigger than 2 and is let's say it x cube minus 3 when it's when x is less or equal to 2. Now we have been asked if limiting value at this and if limit at point 2 exists. Okay, so f of x at x equals let's write it this way. Limit of x tends to 2 minus. What does this mean is that 2 minus means we are approaching from the right side, and writing it this way, limit of x is tends to this process limit of x tends to plus this means that we are approaching the right hand limit value of f of x. This is we are approaching from the left side. That means value is slightly lower than 2. That means this follows you know satisfies this condition. X less or equal to 2. So this time the function would become. First of all, we can write this x as 2 here because the value is very close to 2. So we can basically write 2 here. 2 cube minus 3. 2 cube is 8 minus 3. Okay, so this will be 5. And the right hand limit, that is limit x tends to 2 plus of fx. This times our value is gonna be very close to 2 but slightly larger than it. So it satisfies this condition x greater than 2. So this time it would be x square plus 1. You can again write 2 instead of 2 in the place of x because those values are very close to each other. So this will become 2 square plus 1 or just 5. So here LH left hand limit and right hand limit are the same. This means that limit does exist at this point at x equals 2. Okay, you have been taught about all this in 11th standard. Now what is continuity? Continuity asks if basically the definition is that if left hand limiting value and right hand limiting value and functional value. What is functional value? Where we let's say we have been asked to find the functional value uh, of this function at x equals 2, then we'll be just writing down x equals 2. We are not gonna be writing down x slightly larger than 2 or larger than slightly smaller than 2, not like that. This is just 2, big solid 2. You'll have to first of all comprehend what is going on. Let's say you have a function here that is 2x plus 2, let's say. Now as limit of x tends to 10 of f of x, it would be 2 times 10 because x is very close to 10, so you can write it down this way. Now this time limit can be anything, plus or minus, doesn't really matter because function f of x is defined for both of them the same way. But this is the limiting value, okay? This is the limit value. Limiting value. Now what is functional value? Where we just put x at x equals 10. F of x at x equals 10 would be again 2 times 10 because this time x is exactly 10. 2 times 10 plus 2, and this would be 22 as well. Now you can say that limit of x tends to 10 of f of x is the same as f of x at x equals 10. So this means what does this line is mean? What does this line says? This function f of x is this function f of x is continuous What was the spelling again? Continuous at x equals 10. So what does this basically mean is that if limit of x tends to a of f of x is the same as f of x at x equals a, then we will be able to say that this function f of x is continuous at this point a. So let's talk about this function that we had over here. First of all, let me erase all this. So can I say that if this function is continuous or not? It says that at this point, actually point 2, this says that find if f of x is if f of x continuous at point 2. Okay, we know that the limiting values are the same, that means limit does exist. Now let's find out if this function is functional value is also the same. Functional f of x at x equals 2 would satisfy this condition where x is less or equal to 2. That means it would be x cubed minus 3. So it would be 2 cubed minus 3, that is 5. So limit of x tends to 2 minus equals of if x equals limit of x tends to 2 plus of fx is the same as if x at x equals 2. This means this function is continuous at point 2. Now let's see if it's continuous at point 3. Now this is going to be interesting because now I've been asked to find out if it's continuous at point 3. Point 3, regardless if you take the right hand limit or the right hand limiting value or left hand limiting value, or the functional value, all of the situations are going to be satisfying this condition where x is greater than 2. So for all of them, this would be the value. This would be how the function would look like. This would be how the function would look like. X squared plus 1. So limit of x tends to 3. Now obviously for both hand limits, for right and left, the value is going to be same. So it's really not necessary to write a limit of x tends to 3 minus or 3 plus. But I will still do it because I think you guys are still very new into this. So let me do it this way. Limit of x tends to 3 minus of f of x. We are very close to 3. So we obviously satisfy this condition, x greater than 2. So that means the function would give us 3 squared plus 1, that is 9. Actually, let's not do this one because even this way we'll find out that the value is going to be the same for both limits and the functional value. Let's change it a little bit. Let's check it out if it's continuous at point 2. But at point 2, x is defined as such, x to the fourth, let's say, when x is equal to 2. Now the limiting values for both the right hand side and the left hand side, it would be 5. But if we take the functional value at x equals 2, it would be x to the fourth, that would be 2 to the fourth, that is 16. So now both the limiting values might be the same, but the functional value is not the same. So this means this function is not continuous at point 2. Limiting value for both is gonna be 5, because when you are slightly smaller than 2, we will be satisfying this condition, x less than 2, and function would look like this, x cubed minus 3. So it would be 2 cubed minus 3, that is 8 minus 5, and limit, right hand limit, where x should be slightly larger than 2, will be satisfying this condition, x greater than 2. So that would be 2 squared plus 1. This would also be 5. Okay, so we can say that LHL and RHL are the same. That means limiting value does exist, but this is not the same as functional value. And that is why this function is not continuous at point 2. Okay. So this is where I would like to wrap today's video up. If you guys think that you have doubts regarding anything I have told you guys today, you can definitely ask me anything you want in the comment section. I will try to resolve your doubts. Until then, actually before that, this video is the first video of this series. Of course, more videos are gonna come about the series, and I know that things might seem a bit foggy to you right now, but I promise that over time, after I think a few more videos, after I think 2 or 3 more videos, things should be crystal clear, clearer than the purest of what I have ever seen. I would promise. Okay. So now until those ones drop, keep learning.